So my name is Steven, and I like ropes. Textiles is something that just really fascinates me, and ropes is a simple beginning form of textiles, if you will, that just, I don't know why, it just excites me. When I get to make them and see how they're made and actually get to make something, I get some enjoyment of seeing a raw product and coming out with something that's usable. And so ropes is kind of been something that I've really enjoyed since I was a little kid, since the first time I got to see how a rope was made, and then I started making my own machines. And I have currently been making ropes for 10 years at a local pioneer village, and we've gone to schools and church groups and looking at going to a Renaissance village and getting a rope walk built and installed there. So I've had lots of questions about the machines. I've had people try to buy machines from me, and my machines I had up till now have not been something I felt that I could sell to anybody because they weren't as good of a quality as I felt of giving some to someone. But I have redesigned and built a new machine that is all my putting 2 or 3 different machines together and making my own parts for it. So I want to share that with you, but I want to go through the journey of it. So the very first rope machine I ever had was a very simple 3-wire twisted one, and all it took was a scrap piece of wood just like this, cut it in half, put the 2 over each other, and drill yourself 3 holes like a triangle, 1 on each intersection there, 3 of them. And then what you do at that point is you take a wire hanger, just got one out of the closet, or you can go buy a stiff wire, and you're going to bend it into a 90 degrees, 290 degrees, and on one end you're going to put a little bit of a hook. And I'll put a picture on here of how that looks. And then you take the 2 different pieces of wood, and then you just turn one, and those 90 degrees will twist the hooks, and I'll show you that picture again. So the way that a rope is made is through this picture here. You have individual strands, and you have yarns in there, plies if you will, and those plies are twisted on the individual strands. Once the tension is wound up on each of those individual strands, usually 3 or 4, then there's a counter tension that's released, and those 3 individual strands twist onto each other and bind. Now when you're using this hand style, you have to have a lot of control in it. Those parts of the rope, there are 3 main functions, and it usually takes about 3 people to make a rope. On one end of the rope you have the 3 individual hooks, and when you twist those, the individual strands get tension. So you have to keep it apart. So you've got one person holding the twister, the gears, then you have the other end holding a single hook, and then you also have a divider or a top or a donkey that keeps the 3 individual strands apart. If you don't keep them apart, sometimes they'll twist onto each other while you're twisting them individually. So you have 3 people, 1 on each end, and then 1 holding the top, the divider in the middle. And then as one person turns the hooks and those strands get tighter, the rope will start to shrink. So you'll see on the other end, the traveler that's got the single hook will actually start to shrink as ropes are made, because the fibers, when you first start off, are parallel, they're very flat, and as you twist them, they start to turn almost perpendicular as they tighten up. So the ropes will shrink almost about 1/4 of your original length of yarn that you're using. So as that shrinks, the third person that's holding the top, or the donkey, is going to start to slowly release and let the other end twist. Now traditionally on one end you have a swivel or another hook that the person that's got the single hook starts to twist it and let those 3 strands counter twist, or you could get a swivel and let that natural tension do it, and you don't have to have somebody sitting there actually twisting it. Then the person holding the top, the donkey, starts to walk forward, and the rope binds onto itself. When it gets to the end with the 3 hooks, then you take it and you tie them off, and you've got your rope that's complete. Now with the hand version, the very first one with doing a hand turn, it's very tiring. The longer the rope you have, the more twists that you have. When we counted it out, to make about a 15-foot rope, it takes 400 twists. So this hand version of holding and pulling on the tension and twisting can really wear your hands and your arms out. So we go to more mechanical versions. So we've got different metal and wood versions, and I'll show you some of those pictures here. So one of the first versions of wood that I started to go to is I started looking at the metal ones, and they are a little bit hard to find. They're a little bit expensive. They're aged, so sometimes they don't work really well. They don't spin very well. There's a lot of pressure and tension to them. I saw a model that someone had made with a bench, and I've actually made that here with a bench. And that makes it easier to sit on or put your knee on when you're making it. That also helps keep tension on the rope as you're making it, so you don't have to hold it with your hands by sitting on it or having someone stand on the back end of it. I purchased some blueprints off of a website after failing about a dozen times trying to make my own version of looking at the different types of rope makers that people have. I am by no means a master carpenter. I saw some really beautiful work out there on YouTube of some extremely gorgeous rope machines, lots of lathes and metalworking and woodworking. And I tried to find something that I could do myself. And so I found a design from MK Designs. Their website's no longer up. I did purchase the designs for personal use, but I'm not allowed to share those. But I have since had to make my own designs. I will share everything that I have on here. And what I have attempted to do is I made about a dozen different machines that all failed. You can see here, this is one of the machines. I tried 3 different times on this back end, and I had to flip it over and try it again multiple times. I have about 20 or 30 different gears that I've cut out with the jigsaw, printed them off with paper, and I couldn't, just had the hardest time getting them all to work and to line out. And a big part of that for me was the outer gear. So remember that 1-to-1 when you're doing your hand twist. A lot of the metal ones have a bigger center gear and then smaller gears on the outside. And what that does is it gives a mechanical advantage. When you turn the big wheel, the smaller wheels turn more times. So you turn it once, and then those small gears will turn 3 or 4 times. And the design here has a planetary gear. This one here, I have a cutaway on, so you can see the outer planetary gear as it spins around, moves these inner gears. And so this is a 4-to-1 ratio. There's 24 gears, teeth on the outer one, and there are 6 on the inner one. So every time I go around once, each one of these hooks go 4 times. So rather than 400 turns to make a rope, this one, 100 turns can make the rope. Now this particular one right here, this is from that MK Designs, and you can see that it moves fairly smoothly. And this is one of the ones I like for demonstration, but the problem that I have is when I put this on the machine and actually put rope and tension on this thing, it will start and then it will just lock up. So the problem that I have found is this outer gear has too much slack on the inner gears. So when there's no tension on it, it moves really smoothly. But as soon as tension's put on those hooks, that little bit of slack locks those gears up where they're not smooth to run on each other. And I have tried remaking the inner gears 5 or 6 times. I've tried remaking the outer gears. And if I get away with the slack, then it's too tight and it won't turn at all. So I've been kind of plagued with trying to figure out how to give it enough slack to turn, but to not bind up on me when we turn. The big difference between this wood one and the metal ones, like this, is there is a center hook. So this design is missing one component, and that's a center, because if you put it center in here, this outer gear doesn't touch the center. So there's nothing holding this outer gear in the rotation other than these 3 gears. That's the only thing keeping that outer gear there. So what I have done with my version is I added one more hook. So this version is very similar. There's still a planetary gear, and there are still 3 gears on the inside. Now the difference is the gear is completely bound inside, and I added a back to it. And so now when I turn it, I'm actually not turning the gear. This is glued to the gear that's inside the middle ring. This outer ring is holding the back of the gear, but by having this extra back on here, it allowed me to put a bolt right through the middle and to put a center axis on it. So what that center axis does is it keeps that middle gear completely centered. So as you spin, I have no tension, very easily turned, and those 3 gears you see spinning. And this one, when I put the rope on it, it works extremely well with no tension whatsoever on the binding. Just really smooth. And I've got a video for that. And then this guy here is my Traveler. It has just a little bit of weight in the back, and then it's got kind of a curved shoe so that as it's sliding, it can slide around on the ground there with the wheels. And then on this side, I used to have just a regular hook with a bolt, and it spins pretty smooth, but I'm still getting a little bit of tension on it. So I wanted to get that to run a little bit smoother, and so I bought a hammock swivel. And this hammock swivel has bearings in it, so it's very, very smooth. And then we've got a local blacksmith that I had him make a little S-curve for us, so that when we're putting our yarn on there, it's got a hook to hang on it. So those are the pieces that we have now. And I'm currently making a second one. Here are the boards. And this bench is about 2.5 feet. And then 10 inches wide. And then I have it so that the gear face just slides in this little front slot here, because I've made multiples just 10 inches wide with the idea that I could slide them in. So I'm going to make another bench, and I'm going to make another Traveler to help. And what I ended up doing was I had an old TV entertainment center that was given to me that was going to get thrown away, and I took it and I broke all the boards off of it, and I cut them to make the machine with. And so here are the parts currently. Okay, so here's the back end, and I've got the hole through the center there for the center axis. Now what I did with these holes here is as a triangle, all 3 sets, they're off by a 1/16 of an inch. So when I line the gears up, if I need a little bit more tension in the gears, I just move them over one. You can kind of see how this one and this one, how they're further apart from the center. So I can rotate to make sure I get the gears the right distance for the tension that I need on that part. And then that guy, here's my gear with a back glued onto it, and this is going to go here like such. I don't have the center axis hole here just yet. And then I have this piece here that goes around the outside to hold that in, and then I'll screw the handle on here, and it'll be just like that one. So this piece right here is what's going to go onto that second bench. And then here are the gears that I have. And the way that I get that to work is I have a 1/4 inch eye bolt, and then I use my vice grips and I pull this eye hook open to make it a hook. And then we use these guys, which is called a T-bolt, a T-nut. There you go. See, it's got teeth in it. So I take this guy and I'm going to actually take it into my vise and I'm going to press it. I'm going to ream the hole out just a smidgen. And this guy has teeth. And I'm going to press it in one side. Then I take my eye bolt that's been spread out. I feed it through this side here, and then I put my gear on this side. And the T-nut's going to be right here, so I'll tighten it up so that it's flush with this end. And then we're using a little bit of Loctite, blue Loctite, to keep the thread on the gear. Now, before you put the thread on the gear and just shove the gear in, what I found is I have a lot of gears and they don't all fit and they don't all work. So I like to do this little test. See how I can get it to spin like this? That's a good sign. With this, you can see here I have lots of these guys. Now if I put it here, okay, that one looks like that one would fit. Let me grab another. So take my gear and I start, see right here, it's starting to bind right there. So that means this is not a good fit. I've made so many of these, and then I've had to undersize these guys or undersize this outer gear. You can see this one's, the teeth are a little bit smaller than these so that it doesn't bind up. But then you have to also then make sure that you take this and you have to space it on these wheels to make sure that it gives enough tension, because each one of these are slightly unique depending on how you cut them out. So then once I press the T-nut with the teeth into here and I figure out the spacing, then I put 3 screws in the back guide here, here, and here. So that there's a nut going straight through here for the center axis. But other than that, there's nothing else holding this in. This guy here is just big enough to cover so that see, there's still a little bit of float, but not near. See, I can't move it up and down. That's the big difference, is that center axis. I think with my design, that is the only difference that matches the metal machines, so that there's no give on that center axis.